Okay, so we're going to look at our second Venn diagram example. In this problem, I'm not going to be given percentages, but I'm going to be given the total number of people. So when we do our Venn diagram, we have to fill in the total numbers of people that fall into each category. So here's the problem. Suppose we have a total of 80 students, 35 of whom play basketball, 26 of whom play soccer, and 30 who don't play either sport. In choosing a person at random, find the following. So one thing we want to notice right away is, if I add all of these students up, I get more than 80 students. 30 plus 35 is 65, plus 26, 65, 75, 85 is like 91 students. So I have some students that will fall into more than one category. And before we go to do any of the probabilities, we first want to complete our Venn diagram. So again, I need to recognize we have 80 total students, and I'm going to set up a Venn diagram with circles representing basketball and soccer. And in this case, I still would like to figure out how many people are in the overlap first, but I can't yet. I first have to think about of these sort of 4 areas. So there's an area outside of both circles. There's this area in basketball, but not in soccer. There's the area in the overlap. And there's the area in soccer, but not in basketball. Of the 4 areas, I actually know one number. It's the 30 who don't play either sport. So those 30 people are out here. Now I know that I have a total of 80 students. So if I take 30 students away from the 80, I'm left with 50 students who compete or play in one of those sports. But I have 35 who play basketball and 26 who play soccer. So if we add those up, 35 and 26, that's 1, carry the 1, 3, 4, that's 61 students. So 61 play one or both of those sports, but we only have 50 students left. So that means that 11 of those 61 must play both sports. That 11 is the overlap. So again, I took off the 30 who don't play any sports. That left 50 students. And then we only have 50 who play sports, but I have 61 people. So of those 61, 11 of them must lie in the middle or lie in both circles. So I'm going to put an 11 here. And then we have to figure out how many are in each of the other spots. So if 26 total play soccer, it means there are 15 more who play soccer. So 15 and 11 is 26. I got that up here. 26 minus 11. That's the 15 for soccer. You can do the same thing for basketball. If there are 35 total and 11 play both sports, that means that there are 24 who just play basketball. Sorry about that, guy. Let's fix that. Oh, don't do this. Come on. Okay. I hit a button and then it does this crazy thing. I don't know why it does it. But I have 24 on the next page, so I'm just going to go to the next page. So there's my Venn diagram where I have 24 who just play basketball, 11 who play both sports, 15 who play just soccer, and 30 who don't play either sport. I went back. Let's see if I can just get this 24 filled in here. Nope. Okay. It's not letting me move the pen without writing, so guess not. Okay, so switch to this Venn diagram here. Once we have the completed Venn diagram, it's going to make the rest, finding the probabilities, a lot easier. So strongly suggest that you focus on getting the Venn diagram right, and then we move on. So what's the probability a student chosen at random? So again, we're choosing one person at random up here. And we're finding the probability that person plays basketball. Well, we know that 35 students play basketball and there's 80 students. So that probability, we don't really need the Venn diagram for. 35 out of 80, 44%. In choosing one person, what's the probability they play soccer? Similarly, we know that 26 out of the 80 play soccer, or 32.5%. Next part says, what's the probability they play both? So there's where I might start using the Venn diagram. I wouldn't know this value of 11 unless I'd figured out the Venn diagram first. I might think to add the 35 and the 26 total together to say, oh, they play both sports, but they don't all play both sports. Only 11 play both sports. And notice in this example, we're having to divide each time by 80. It's because we didn't have any percentages to begin with. We just knew how many people were in each thing. So of the 80 students, if I choose one randomly, we have a chance of 11 out of 80 that they play both sports, or 13.75%. Probability they don't play either sport. So, you know, I could have notation. It's not B and not S, but sometimes it's easier just to write the words in like I did here. The probability they don't play either sport. They're not inside either circle. That's 30 out of 80. The 30 people, and that's given to us as well. So we wouldn't necessarily need the Venn diagram for that, but you can see them up here. It's these 30 people. Okay, so then we'll look at the two trickier things, the or and the conditional probabilities. So the probability they play soccer or basketball, so that's anyone in either circle. So I just add them up, 24 plus 11 plus 15 to get the three totals that are in both circles. And again, divided by 80. That's 24, 25, 35, 40. That's 50 out of 80, or 62.5%. We could have gotten that as well. You know, there's 80 students, 30 don't play either. So 50 must play one sport or the other, or both. Okay, last two are conditional probabilities. Find the probability they play soccer, given that they play basketball. So switch back over to my pen, hopefully. Be nice again. Draw. Set up my fraction bar here. I want to do the people who play basketball first. Everyone who plays basketball, that's 35 of them. And then of those, how many play soccer? 11. So that's 11 out of 35, or 31%. The next one, also conditional probability, slightly different. I'm looking for the probability that they play basketball given they do not play soccer. So again, I'll set up my fraction bar. I'll do the denominator first. How many total people do not play soccer? Well, there's over here 24 inside of basketball plus this 30 outside of both circles. So there's a total of 54 people who don't play soccer. And how many of them play basketball? That's the 24 that I underlined up in the Venn diagram. 24 out of those 54 play basketball. So the probability someone plays basketball, given that they do not play soccer, 24 out of 54. Or 44%. Okay, so that's ending our second Venn diagram problem. I'll leave this here for a second, so if you want to get these results copied down or look at the answers final, and then I'll probably do at least one more, maybe two more. No, probably just one more. All right, thanks.